I'm Anil Kumar. Here is an excellent question, and this is for our new subscriber, Matt. Matt, you're most welcome to this group, and I'm really happy to see your request on a very interesting topic, uncertainties in measurements. And now, I was actually developing material on this, and so it took time to respond to you. Meanwhile, I thought, let me share a video with you which directly answered your question based on uncertainties in measurements for a golf ball. So I hope you found that interesting. Now, here is an excellent example from one of the test papers, which is for Indian Institute of Technology joint entrance examination. So this is a very prestigious entrance examination to the Engineering Institute in India. Now the question here is, the following observations were taken for determining surface tension T of water by capillary method. Diameter of capillary D equals to 1.25 into 10 to the power of minus 2 meters, and height of water rising H equals to 1.45 times 10 to the power of minus 2 meters. Using G equals to 9.80 meters per second and simplified relation, the surface tension T equals to RHG over 2 times 10 to the power of 3 newtons per meter. The possible error in surface tension is closest to what? 4 choices are given to you. Now this is an extremely difficult question. I don't know whether should I be taking this at this stage or not. But anyway, I'll soon support it with another video which will give you a lot of basics. Okay. But here is one of the best questions on this topic. Let's see how to work with this particular question. Now here we are given a couple of things. We are given the diameter D, which is 1.25 into 10 to the power of minus 2 meters. We are given height as 1.45 into 10 to the power of minus 2 meters. The gravity, force due to gravity, is 9.8 meters per second square, and the formula itself, which is T equals to R. So R is the radius, right? So if I convert this radius to diameter, I could write this as diameter times, R is diameter over half. So I could write this as over 4, right? So this is 2 times 2. So I replaced R, so I wrote R as diameter over 2, since we are given the diameter, right? Into 10 to the power of 3 Newton meters. Now, the complication here also arises not only from the complicated formula which you see here, but directly we are not telling you what could be the error in measurement of diameter or height or gravity or whatever, right? So this is one part which we should understand. So let's understand this and then we'll get into the solution of this particular question. Now when I say that the diameter is 1.25, the uncertainty actually revolves around this last unit, right? So this has been approximated. Similarly, for height, that is what is being approximated. So that results into errors. As far as gravity is concerned, what do you think? Is there uncertainty involved here? No. Gravity is a constant, right? So we are taking this value. We are not measuring it, right? So in this particular observations which we are talking about, we are actually not conducting any experiment to find the value of G, right? So we take it as a constant. So here, no error. So that is first thing which you should understand when we are given this type of a question. Now, coming back to the formula, which is definitely a simplified version, does not have the cos, the trigonometry part of it, right? So anyway, so we are not bothered about the real formula. We are only bothered about what is given in the test paper. We simplified this a bit since we had diameter, right? So, okay. So that makes sense. So if you look into this formula, you know that the error involved is mainly because of these two, right? these two. So it should get added up and then we should find the answer. So if it is a multiple choice question, you can actually write down the answer very fast, right? So, but provided you know what the error is. So in the first case, what is the error? So when we say diameter is 1.25 into 10 to the power of minus 2, in that case, what are we saying? We are saying that the change or the error in diameter, that is delta D, delta D could be what? Right? So what that could be? So diameter could be 0.01 into 10 to the power of minus 2, since the error is at this place. So this could be 0.01 into 10 to the power of minus 2. Do you see that? So the error in the diameter in this measurement will be at this place, right? So the significant place at which we can have an error is our focus. Similarly, for the height, it is also 0.01, right? 0.45. You get the idea? So that is the place where we could have the error. Correct? And so that should help us to figure out the solution directly, right? So we can actually find our answer by multiplying, because I'm not going into the details, but I'll take up the formula also, derivation, and provide you with the solution. Or rather, well, let's go to the method. So we'll talk about method now. Okay. And come back to this. Fine. So first thing which we have understood from here is that the error involved in the measurements of diameter will be 0.01 10 to the power minus 2, and in height will be 0.01 10 to the power minus 2, and no error in the other constants which we have taken. So that's it, right? So okay, let me move on to the next page and we'll actually understand the process, so the calculus behind to get the result, right? So you can say this was a shortcut which I was jumping into, but let's use calculus to get into the method of solution. Perfect. Then we'll come back to this. So here I have copied all the values which were given to us. We'll begin with the formula itself. The surface tension T is equal to, so instead of R, I'm writing D over 2, right? So I'm writing straight away D, and then we'll write H, we'll write G, and instead of 2, I'm writing 4, since I wrote diameter instead of radius, and we have 10 to the power of 3, right? The units are Newton meter. So to solve such a question, what should we do? We need to take logarithms on both the sides. So we'll take log and then derivatives using logarithms. So we get log of tension T is equal to log of the diameter plus log of the height plus log of the gravity part, right? So plus log of all this constant, right? 10 to the power of 3 over 4, correct? So we get all these, right? Now we can differentiate both sides with respect to something, right? So we could say dx, change in something, right? So now let's take derivative. Now we'll differentiate with respect to x, right? So some variable. So when we differentiate to find a small change, then what do we get? So in this case, we get dt over, derivative is t, right? So 1 over t, right? So we get dt over t, and here we get d diameter over d plus change in h over h plus these derivatives are 0 because they are constants, right? So these derivatives are zeros because they are constants. Correct? So that is what it is. And now, since we know we want to find the possible error, it's always the percentage error which we are looking into. So what we do after this stage is that we just multiply each by 100, right? So we do 100 times delta T, just this change in temperature, and this is change in, tension, right? Surface tension. Okay, diameter. Okay, and change in height. Correct. So that becomes your general formula, which I was about to write there, and I didn't. So now that is how you kind of get its derivation using the derivatives in calculus. Correct. So that is how you get. Now we know all the figures, right? So we'll substitute those values and use calculator to calculate. So what you see here is all those numbers, they don't really reflect on the error part. So the actual measurements being done on the two things, they only contribute to error. Perfect. So percentage error, we are trying to find, since these values are given in percent, that's the whole idea. So that is why I'm multiplying by 100, right? So now what was the error which we talked about? Okay, so we have to check this. So we have the error in measurement of tension. So percentage error in this is equal to, so we multiplied everything by 100. So here the error in the measurement of diameter was 0.01 into 10 to the power of minus 2 divided by actual diameter measured, which is 0.125 into 10 to the power of minus 2, correct? Plus, similarly, for height, it is 0.01 into 10 to the power of minus 2 divided by 1.45 into 10 to the power of minus 2. Correct? So that is what you get. So this was a shortcut method. We could have just applied it there and got our answer. But I hope now it makes more sense, right? So basically, we have to just use calculator to find these values. You know, these cancel away, correct? So this is what we have to find. So let's do it. So we have 0.01 divided by 1.25, right? And we'll add to this 0.01 divided by 1.45, right? And then we are going to multiply this by 100 to get our answer in decimals. It is closest to, so what we find here, it is 1.48%. Correct? So 1.48% is closest to 1.5. Perfect. So that is how you actually get your answer. So getting back to our original page, let's go back to our original page and see where we were. So it is right here. So we could have straight away, right there, written the changes, which is, 0.01 over the original, which was 1.25 plus 0.01 over 1.45, correct? Those 10 to the power of minus 2, 10 to the power of minus 2 will cancel. So by writing this, we kind of get a shortcut. Now this is very essential for a multiple choice question, and especially for an exam like this where you need to save some time, and if it is just a multiple choice question where the method is not giving you any additional marks, why not, right? So just do this and get your answer. So I hope that makes sense. Feel free to write your comments and share your views, and if you really like and subscribe to my videos, share it with your friends, and soon I'll come up with the theory behind all this. Thanks. So Matt, once again, thanks a lot for sharing your views, and keep sharing the questions which you come in your mind. Thank you, and all the best.